Hello friends, I hope you are enjoying this neural network series. In the beginning, we discussed about simple predicting machine, which was taking one input and giving one output, and it learned to convert kilometer into mile from the available data. Then we talked about simple neural network, which was taking two input and giving one output, and it learned to predict color value from the available data. Today we are going to discuss about a layered neural network, which is the most common type of neural network. And in our example, there will be one input layer, one output layer, and one hidden layer. And all magic happens in this hidden layer. Yes, initially it looks like a magic, but when we uncover it, then there is a mathematics behind it. And today we are going to explore it. So let's have a curious talk on this. Now see this image. This is a structure of a layered neural network. It has two input and two output. One input layer, one output layer, and in between there is one hidden layer. All these circles represents nodes. All these connections represents weight parameter. There are also additional parameters, those are known as bias. If this image looks overwhelming, then let's start with a simple example. There is a pair of student and teacher. Student tried to solve some equation. He predicts the value and so to the teacher. Teacher compare it with real answer and tried to make it correct. Student again predicts some value with less error. Again teacher tried to make it correct. And this process was repeated until student become learned. In this analogy, student is neural network and teacher is backpropagation. Backpropagation is the most important algorithm in the neural network. And let's understand how backpropagation works. First step is feed forward, where predicted values is calculated based on the initial assumptions. Second step is to calculate the error by comparing it with actual answers. And third step is to backpropagate that error and update the parameters. And this process gets repeated until we find optimum parameter and negligible error. Let's understand this process in detail with maths behind it. Here x1 and x2 are input and that is coming from the dataset. W1, W2, W3 and W4 are weights and those are initialized randomly. Value of h1 and h2 is calculated with the help of this equation, where h1 is equal to w1 x1 plus w3 x2 plus b1 and h2 is equal to w2 x1 plus w4 x2 plus b2. This line indicates activation function, and here we are using sigmoid function as an activation function. So h1 is the input of activation function and ho1 is the output. And based on the equation of sigmoid, ho1 becomes 1 upon 1 plus e raised to minus h1. Same as ho2 becomes 1 upon 1 plus e raised to minus h2. W5, W6, W7 and W8 are weights. Those are initialized randomly. Value of y1 and y2 are calculated based on this equation, where y1 is equal to w5 ho1 plus w7 ho2 plus b2 and y2 is equal to w6 ho1 plus w5 ho2 plus b2. y1 and y2 go to the sigmoid function and yo1 becomes 1 upon 1 plus e raised to minus y1 and yo2 becomes 1 upon 1 plus e raised to minus y2. This was the feed forward step. Now step 2 begins, that is calculating error. Here error of the first output is E1 and error of the second output is E2, which is compared with the actual value, and actual value is known as target. Actual value of first output is T1 and second output is T2. Here E1 becomes 1 upon 2 T1 minus yo1 square and E2 becomes 1 upon 2 T2 minus yo2 square. Total of error Et is equal to E1 plus E2. And Et is also known as cost function. This cost function is mean squared error. That's why it is divided by 2 to average out. Here Et is equal to 1 upon 2 T1 minus yo1 square plus T2 minus yo2 square. That's how total error is calculated. This was the second step. Now third step begins, where error is backpropagated to update the weight parameters. And weight parameters are updated with the help of gradient descent algorithm that we have already seen. According to gradient descent algorithm, new value of weight is denoted with Wn. where Wn is equal to W minus eta, that is learning rate, into del Et by del W. Here Et is cost function or total of error. In this way, weights are updated in this layer. This error is propagated up to the first layer, and in the same way, weights of first layers are also updated. All parameters are updated now, and now first step of feed forward is repeated with the updated parameters. And this process continues to repeat itself until we found optimum values of parameter that makes error negligible. That's how training of neural network is done with the help of backpropagation algorithm. Once neural network is trained, it becomes capable enough to find unknown values by its own with a good amount of accuracy. For a quick recap, I am repeating this animation. So please have a look. I hope you enjoyed this animation. Now we have covered the most important algorithm of the neural network. In next video, we will take one mathematical example to solve it with the help of chain rule. So stay tuned. See you in the next video.